4.5 today. We want to continue to simplify expressions involving radicals. There's a couple of that we didn't talk about yesterday that involve fractions, and it looks a little different than when the ones we did yesterday. We have 3 over 7 plus root 2. Now, if it was just 3 over root 2, you know what to do, right? We just talked about that. Multiply top and bottom by root 2, you got it. But what happens, and don't write this part down because this is not going to work, but I'm going to show you why. If I were to multiply top and bottom times root 2. Here's what happens. If I take 3 times root 2, I get 3 root 2. Okay, that's good. If I take root 2 times this, I have to distribute it. So I wind up with 7 root 2 plus 2. I still have a radical in the denominator. Not going to work. So here's what you need to do. This part you're going to need to write. Okay, we're going to multiply by conjugate. What a conjugate is the numbers are the same, the sign between them is different. So here I have 7 plus root 2, its conjugate will be 7 minus root 2. You do the opposite. Yep. So now, if I do that times the bottom, I have to do it times the top. Now here's why this works. We're going to FOIL this out on the bottom. So 7 times 7 is 49. 7 times negative 2 is minus 7 root 2. 7 times root 2 is plus 7 root 2. And then the last one, root 2 times a negative root 2 is minus 2. Okay, that middle term there, those two middle numbers, what's going to happen to them?
And cancel out.
They cancel out, so now I don't have a root anymore. Okay, now we have to do the top part too. 3 times 7 is 21. 3 times negative 2 is minus 3 root 2. And then we just need to finish. This top part is still 21 minus 3 root 2. And on the bottom I have 49 minus 2. What's 49 minus 2? 47. Okay, now at this point you have to check. Is there any factor that goes into 21, 3, and 47? All three of them. Well, 3 goes into 3 and 21, so that's a good one to try. Is it going to go into 47? It's not. And here's how I know really quick, just to remind you, the little trick. If I take 4 plus 7, it equals 11. If that's not divisible by 3, 3 won't go in there. So in that case, we're done. Can't simplify that any further. Okay? Let's try one more of those.
Those are so confusing.
So I have negative 6 over 7 minus root 5. So what am I going to multiply times top and bottom? 7 plus root 5 on the top and on the bottom. Okay. Let's do the top first this time.
Wait, how do you know it's like the addition?
Because it's a minus here.
Yep.
So it has to be whatever the opposite is. So I have a negative 6 times 7 is a negative 42. Negative 6 times root 5 is minus 6 root 5. That's my top. Now my bottom, I'm going to let you do a little shortcut here because we know, because we picked the conjugate, that the middle is going to cancel, right? So if it's a conjugate, you can take the first times the first. So I get 49 minus the second times the second, which is 5. Now be careful, this only works with conjugates. If you have regular foiling, you got to do it all. Okay, so you can do this shortcut, but only if it's a conjugate.
When will we ever
44. Okay. Now, this one can simplify a little more. What goes into 42, 6, and 44? 2. Now, in order to show you the right way to cancel, here's what we're going to do. I'm going to actually factor out a 2 from both of these. So I get 2 times negative 21 minus 3 root 5 over 2 times 22. When it's written like that, you can cancel the 2's. You cannot look at this and say, okay, I'm going to cancel a 2 here and here and not worry about the other term. It has to come out of all 3 of them or it doesn't work. Okay, so my final answer, negative 21 minus 3 root 5 over 22. Okay? Yes.
So instead of doing all of that, couldn't you just take the 2, as 2 goes into like 4 twice, so couldn't you just do a negative 2 and 2 goes into 1, and then since 2 goes into 3, do you get what I'm saying?
Well, that you can look at them and just go straight
instead
from
of
this
writing it
step
all
to that
out,
step.
since you know what it goes into, can't you just do like negative 21 over
Okay, and I understand what you're saying. And the easy answer is yes, you can do that. However, my experience tells me that students tend to forget terms when you do that. So I want you to practice doing it this way, at least for a while. As long as you're getting them all, you can, but make sure you probably need to practice it this way because, like I said, my experience tells me students tend to forget a term in there somewhere. They look at it and say, well, it goes into 1, and so that'll be good enough, and they forget that it has to be all of them. Okay. Okay, so now we're going to use our square roots to solve equations. And if I solve an equation, what does my final answer need to look like? It's x equals something, right? You're going to solve for your variable. You can't just quit in the middle. Okay, so if I have x squared equals 36, you guys know how to do this one. What's x going to be? Now, how many answers does a quadratic equation have? 2. What's my other answer? Negatives. When you take a square root, you need to be sure and consider both the positive and negative solutions. Now, if it looks like this, if there's no something times x term, you can solve it using your square roots. But first, you have to get x squared all by itself. So I'm going to say minus 5 on both sides, and I get 3x squared equals 36. But x squared isn't alone yet, so I still have to divide by 3. And I get x squared equals 12. So now I can take the square root of both sides, and I get x equals this plus or minus the square root of 12. But just like we have been doing, you have to simplify. So that's plus or minus the square root of 4 times 3, but the square root of 4 is 2. So it's plus or minus 2 root 3. Okay, so hopefully you worked through all that worksheet yesterday and it made sense because you're going to have to apply them today at the end of the problems. You should be able to do them real quick. That practice thing again. Okay, questions on that one? Now, a couple more examples. They get a little more complicated as we go. This one you can also use a square root to solve because we have this in parentheses. X minus 2 is in parentheses squared. But I still have to get the squared part all by itself first. So I'm going to divide by 3. And I get x minus 2 squared equals 40 over 3. Now I'm going to take the square root of both sides. And I get x minus 2 equals plus or minus the square root of 40 over 3. Now, I haven't got x by itself yet, but I'm going to work on simplifying this thing first. So I'm going to kind of do a little deal off on the side. So, square root of 40 over the square root of 3. Well, what perfect square goes into 40? 4. So that's the square root of 4 times 10 over the square root of 3. So I get 2 root 10 over root 3. Now I need to get that radical out of the denominator. So I take times root 3 over root 3. So I have 2. 10 times 3 is 30, so 2 root 30. Root 3 times root 3 is 3. So that's what 40 over root 3, or square root of 40 over 3 is. So I have x minus 2 equals plus or minus 2 root 30 over 3. Now I need to get x alone. So I'm going to add 2 to both sides. And I get x equals 2 plus or minus 2 root 30 over 3. And remember, that's two solutions. The first solution is 2 plus 2 root 30 over 3. The second solution is 2 minus 2 root 30 over 3.
So I did it a different way. I'm wondering why it couldn't work.
Okay, what did you do?
I have a different answer, but the x minus 2 is in parentheses squared. So I just factored that out.
So you factored it out. How did you factor it out?
Well, just x squared plus 2x minus 2x.
Okay, so you foiled it. Okay, gotcha.
Okay. So then my answer was 3 times x squared minus 4 equals 40. And then you can just subtract the 4.
Okay. When you foiled it, did you get x squared minus 4x plus 4?
I got x squared minus 4.
Okay, you're missing a term. Remember the FOIL thing? When you have x minus 2 times x minus 2, you have to FOIL. So that's x squared minus 2x minus 2x plus 4.
Oh, I see.
Okay, that's where you got in trouble. Okay, so be careful. It's real easy when they are squared like that to think, oh, I can just square both of them, but it doesn't work that way. Yep.
Where did you get it says x equals 2 plus or minus 2 over 30 over 3? Where did you get this 2?
This 2 right here, right here.
Oh, okay.
Okay, so I added 2 to both sides so I can make x by itself. So then you do that. Okay, any others on that one? One more. This is the trickiest one here. So it's going to use everything, all the different
So
things
these
that
are
we
going to
use.
be like number 4, big hard name is
Yes?
going to be what is going to be on all of our sides.
Not all of them, but there might be 1 or 2.
Or 5 or 7.
Okay, here we go. We need to get the squared part by itself. We're not going to distribute. We're leaving the squared alone. So we're going to subtract 4. 3 times x plus 2 squared equals 9. Now, what do I do next? Divide by 3. So I get x plus 2 squared equals both sides. It's gotta be plus or minus over here. So I get x plus 2 equals plus or minus the square root of 3. Well, 3 is simplified as much as it can get under that radical sign. So all I have to do is minus 2, and I get x equals negative 2 plus or minus root 3.
So how is that uncomplicated? And that seems so much easier than the
Well, it looks scarier when we started, right?
It seems
So there's
easier
more
than
stuff
one.
here.
You're too smart.
It just didn't require as much simplifying.
It just looks intimidating.
So sometimes they're not as bad as you think.
Miss Redmond, you're a pro.
Thanks. Okay, now it's your turn to do the same thing.
I can't. I'm not.
You can do that. Now, I'm going to show you a little trick on simplifying radicals when you are multiplying them. Okay, if you can factor things, a lot of times, you can save yourself a whole lot of work. I want you to try to do these as much as you can without your calculator.
So is that like the square root of 27 times the square root of 18?
Yep.
Shouldn't that be true?
What's that?
Okay.
Oh, yeah. It is.
Because you did that one.
Okay. So, number 1. Root 27 times root 18. I'm going to have you write root 27 as 3 times 3 times 3. Right?
But just like in office are doing it wrong.
Okay. Now, and let me show you a little trick to this. If you don't remember the prime factors, you know that 9 times 2 makes 18, and 9 is just 3 times 3.
So can you do 3 times 3 times 2? So are we just going to like cancel out the 3?
Okay, so now we're not going to cancel them out, but we're going to group them up. So here's what we're going to do. You know when you multiply 27 times 18, you're going to have 3 times 3 times 3 times 3 times 3 times 2, right? And then you multiply all that together. So, we're going to do a little bit ahead of time. I've got 3 times 3 is going to be under the square root sign, and this 3 times 3 is going to be under the square root sign. What is the square root of 3 times 3? 3. What is the square root of this 3 times 3? So on the outside of the root sign, you're going to have 3 times 3 equals 9. Okay, now, yes. And then you look at what's left. I have this 3 and that 2. That stays under the root sign. So I have 3 times 2 is 6, and I get 9 over 6. Now you are welcome to multiply 27 times 18 and get this great big number. And then try to figure out that 81 goes into it. You can do it that way. But this is a shortcut for you. Okay, let's look at this one. Let's factor 20.
Okay.
2 times 10. Yep, you can do that too.
Okay, because I feel like it's quicker.
Okay, if that works, that works. That's not a problem. Okay, and 24, back to that one.
That's going to be 12 times 2 and
Okay, and now remember that you only use the bottom ones. Sometimes when you do this, you get confused on which ones to use. Just these bottom ones are the ones we use. Okay, so now let's look. We have 2 here and a 2 here. And we have 2 here and a 2 here. So this pair, its square root is 2. This pair, its square root is 2. So outside the square root sign, we have 2 times 2. And inside the square root sign, what do we have left? We have a 5 and a 3. So the square root of...
that 2 next to 6. No, because you
Oh, yes, you should use that. I do have one. You're right.
everybody makes mistakes, Miss Rhoda.
Oh, I'm sure appreciate that, sir.
Oh, I just want.
Okay, so you've got 5, 3, and 2. So we have 4 root 3. Okay, so now, Casey showed me another one, and I'm going to talk about it real quick. This one you could say this is 3 root 3 times 3 root 2. 3 times 3 is 9 root 6. You get the same answer. Now, the only thing that can happen when you do that, there's nothing wrong with that, but sometimes you'll have to simplify this last one again, because if there's a 2 over here and a 2 over here, and they get together when you multiply, you might have to simplify one more time, but that's, just be aware you need to do that. That works too.
Can
Nothing
you do
wrong
that
with it.
way on the second one, because I got 2 root 6, and I got 2 root 5. 2 root 6 which one?
2 root 5 times 2 root 6 equals 4 root 30. Works the same. That's fine. Yep, that's a correct answer. Yep. So it works both ways. Okay, there's lots times more than one way to do it, and if you have a better way for you, by all means use it. Okay, that's all I have